Welcome to a video by Abron. This is LCR resonance separators with the oscillator. This is the oscillator setup in this. Although you can use the external oscillator also, but we have provided the oscillator. Let me tell you, this is a dial frequency which is up to 10 Hertz, and then there is a multiplier into 10x, into 100x, into 1000x, and this is amplitude. They are provided with the two AC milliammeter rectifier type, and this is also voltmeter rectifier type. The circuit is having a series. This one is a series circuit where R, L and C. This is resonance separators for checking in series or in parallel. This one is in parallel. These two are in parallel. There are resistance also selectable with the this dial tone where you can select by knob, and there is another capacitor which is also selectable with the two output connecting. There an oscillator also has the output. Even the meters has the output of both these two, and this circuit is how you have to make. Let me tell you this circuit first of all. Very easy. You can connect the capacitor. You can connect the capacitor by connecting it to the, this is one is a capacitor here. You can connect the capacitor with the positive and positive. And if you want to connect the resistance can be connected in series or parallel. But to be easy, it is better to connect the negative to negative and positive to positive. Then this is oscillator, and these are meters. I am connecting this meter, positive meter, and this one is a circuit has a voltmeter here. I am connecting this voltmeter. You can see this is how voltmeter is connected with this circuit. Now I am connecting the ammeter. This one is ammeter. I am connecting in the ammeter. This one is ammeter in the circuit. Here it is positive, negative and negative. See this. Now this meter is connected here. Voltmeter is connected here. Now the only thing is oscillator. I have to connect it oscillator. Here you can see the oscillator sign is there. So you can connect the negative also. Now it's very easy. Now the circuit is complete with all the circuit. You see this manual, it tells you the theory, what are the different parts, what is the theory of it, how the resonance in series, this one is in series resonance is done. You have to note the frequency, current and voltage, and similarly you will get the graph like this, frequency across the current. Similarly for parallel, there is another top circuit. These are two parallel inductance capacitors in parallel, and connecting you can see frequency, current and voltage, they are done. And then you can see the curve is little different than the upper one. It's all together different. So let me show you this one. This is the meter reading by almost milliampere is 0.35 and current is 1 volt, and this is the frequency. I can change the frequency. I can increase the, you can see that if I increase the amplitude, it changes. I can increase the, multiply the resistance, the series. This is the resonance voltage where there is a maximum resonance. You have to arrive and then do the experiment. Similarly on different volts and different resistances, I can go with this, and again go with the resonance where you can see the maximum current takes the circuit and what is the maximum voltage. You can do all the experiments. And similarly this one, see this, there is a huge difference at particular voltage and particular frequency. The resonance is there. So LCR means capacitor, inductance, capacitor and resistance, resonance with the oscillator. This one is oscillator. You can, instead of using this current oscillator inside built in, you can use the external. Similar experiment can be done with a series circuit. Please visit the website. If you like the video, please subscribe the channel and share the video, and you can send abron01@gmail.com. Website is abronexports.com, and WhatsApp number is 9416020018. Please visit the website and send us your order and inquiries of different instruments. We have got all the different kind of teaching instruments for electronics labs and research labs. Thank you.